going to talk now about section 5.2, which allows us to introduce the trigonometric functions. Now, in the last section, we started with the unit circle, and we showed how if I started at a point there in the unit circle, I traveled some distance t, I could get a point, an x and a y value that corresponded to t. Now t could be positive and wrap this direction, could be negative and wrap this direction. Really, t could be very large. It could just wrap around and around, make t hundreds, and it's going to wrap around for a really long time. But t is periodic, which is kind of cool. As it goes around once, twice, 3 times, whatever, it always gets back where it started. So we looked at these real numbers that measured lengths as we traveled around the unit circle and associated those to points on the unit circle. So for this given point xy, we are going to define 6 functions that take in a real number t and spit out a point on the unit circle. That's where the trigonometric functions come from. Sine of t is going to be the y-coordinate. Cosine of t is going to be the x-coordinate. The tangent of t is defined to be let's make that a little clearer. Y over x, which you'll notice is the sine over the cosine. And then we get 3 other ones. We get the cosecant of t, 1 over y, that's 1 over sine of t. We get the secant of t, 1 over x, that's 1 over the cosine. And we get the cotangent of t, which is x over y, which is 1 over the tangent. These names are spelled out in your text and the definitions are given there. Something that I want you to be cautious of as we start evaluating these things, SIN, these are not variables. This is a function. It requires an input and it specifies an output. So, something that I see all too common is that, written by itself. That doesn't really mean anything mathematically until you give it something to work on. Suppose I wanted to find sine of pi over 3. Well, then I'm actually specifying for a given length along the unit circle, I want to know one of the coordinates. Now, let's go ahead and do this one. Let's compute sine of pi over 3, cosine of pi over 3, and then we see if we can get the rest of them. If you remember from the last slide, or if you've got your text out, when t was equal to pi over 3, the point that we actually got for the endpoint was 1/2 square root 3 over 2. So from what we had on the last slide, the sine is the y-coordinate, so sine as a function evaluated at pi over 3, square root 3 over 2, and cosine is 1/2. We can evaluate all the others. Tangent for pi over 3. Tangent was sine divided by cosine. Square root of 3 over 2 divided by 1/2. We get the square root of 3. The cosecant of pi over 3 was 1 divided by the sine. That's 2 over square root 3, or if we rationalize the denominator, 2 root 3 over 3. The secant, pi over 3 was 1 over cosine, which is just 2. And the cotangent was 1 over the tangent. So 1 over square root of 3, or again, rationalizing the denominator, square root of 3 over 3. And those can all be worked out pretty readily. But while the sine and cosine are well defined, no matter where you're looking on the unit circle, these other four functions, they can have some problems. If we look back at the last slide, tangent involves division by the cosine. So cosine cannot be 0 if you want to find the tangent. Cosecant, division by the sine. Secant, division by the cosine. Cotangent, division by the tangent. So we need to be careful in these things and verify that the denominators are non-zero for every one of these that we want to evaluate. So let's look at some examples. And it looks like we got a little bit of an error in the recording, but it's kind of glitched over here to the punchline. So sine of pi is 0, because for an angle of pi, we're going to start here, travel around, and the y-coordinate for that point right there is 0. Cosecant would be 1 over sine, which is 1 over 0, and that's undefined. So the cosecant is undefined at pi. Similarly, for the cosine of pi over 2, it's going to be a distance from here to here. I've traveled that pi over 2. Cosine is the x-coordinate. The x-coordinate right there is 0. So the cosine of pi over 2 is 0, which means the secant, 1 divided by the cosine at that point, again, is going to be undefined. So as you're working through these, trying out some of these computations, you want to make sure that when you're computing anything except the sine or the cosine, tangent, cotangent, secant, and cosecant, that you are always verifying that the angles you're being asked to compute are the distances for t that you're being used as inputs, and the values that you're being asked to compute, that those are always going to be involved in actually the domain of the function you want to work with. They're going to avoid division by 0. And so you can see kind of what the big points are that we need to worry about. There, 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 and there. So when the lengths, if we're just going one time around, where we've got t is equal to 0, t is equal to pi over 2, t is equal to pi, t is equal to 3 pi over 2, and then 0, we get the same thing as if we were at 2 pi. Those are the spots where you need to be cautious when you're computing some of these other trig functions, because those are the spots that could give you a 0 denominator and give you some undefined division.